There are three objectives to this video. First, we will teach you who Kepler was. Second, we will teach you about his three laws of planetary motion. Third, we will teach you how to apply his third law. So you're probably wondering, who was Kepler anyways? Johannes Kepler was a German mathematician, astronomer, and astrologer. He was also a key figure in the 17th century scientific revolution. Kepler inherited 30 years' worth of data from a scientist named Brahe upon his death. He built upon this data and discovered the laws that describe the motion of every planet and satellite. Kepler's first law. The orbit of every planet is an ellipse with the sun at one of the two foci. For example, in this picture, the drawn path of each of the planets is in the shape of an ellipse. This is important as it applies to his second law. Kepler's second law. A line joining a planet and the sun sweeps out equal areas during equal intervals of time. This means that as each planet moves closer to the sun, it also moves faster. Likewise, every planet moves slower as it gets farther from the sun. Kepler's third law. The square of the orbital period of a planet is directly proportional to the cube of the semi-major axis of its orbit. This can be easily rewritten into the following formula: TA over TB squared equals RA over RB cubed, where TA is the orbital period of planet A and TB is the orbital period of planet B. RA is the radius of planet A to the sun, and RB is the radius of planet B to the sun. Now for an example problem. Let's say you wanted to find the period of planet A, or TA. There are three things you need to be able to do this. They are TB, RB, and RA. Step 1. Set up the problem. Step 2. Find the value of RA over RB cubed. This will be represented by the variable Rx. Step 3. Take the square root of Rx. Step 4. Lastly, you will multiply the square root of Rx by TB.